Hello, everybody. Today we are going to see the limitations of crystal field theory. The limitations of crystal field theory can be summarized as given here. The first limitation is this: the crystal field theory assumes that the metal ligand bond is purely electrostatic in nature, but it is not real or true. Completely electrostatic, or it's made up of negative and positive ions, is not the scenario for any bond. So the basis of the crystal field theory is somewhat not realistic. That is the first limitation. Then the second point is the theory takes only the orbitals of the central atom into the account. So we are we are considering the metals, the orbitals only, and with that idea in mind, we are explaining about all the properties of coordination complexes in the case of crystal field theory. But there are other orbitals of the central metal atom, like p and s orbitals. These can also take part in bonding, but these are not considered in the case of crystal field theory. In crystal field theory, only d orbitals are considered. So this becomes one of the drawback of crystal field theory, because it neglects s and p orbitals. And third point is that this theory fails to explain the behavior of certain metals which cause large splitting and others having small splitting. When certain ligands are coming, there will be larger splitting, and corresponding to it, there will be larger crystal field energy. And while some other ligands, when they are interacting with the metal d orbital, there will be smaller splitting, or the energy gap between the splitted or split orbitals will be less. And this is not explained clearly in the case of crystal field theory. For example, H2 is a stronger ligand compared to OH minus. Why this is happening is not explained in crystal field theory. Also, OH minus is a negative ion. So if we are considering the metal ligand bond as a purely electrostatic or made up of charges only, this OH minus should split the d orbitals to a higher extent, but it is not the case. H2O is making a higher crystal field splitting in the case of metals, d orbitals. So a satisfactory explanation for this is also not given by crystal field theory. Then the fourth point is that this theory rules out the possibility of p bonding and pi bonding, because in many complex there is pi bonding that is happening. This is not explained because in crystal field theory we are considering only d orbitals. P orbitals are not considered. Then the fifth point is that the theory gives no significance to the ligand orbitals. It gives all the importance to the central metal atoms orbitals, while neglecting the ligand orbital. Therefore, it cannot explain any properties related to the ligand orbitals and their interaction with metal orbital. As I said earlier, why certain ligands cause different splitting for a particular metal compared to certain other ligands is not explained using crystal field theory. This can be explained only if we consider the ligands orbitals, how they are going to interact with the orbitals. But this is not considered in the case of crystal field theory. The sixth point is that according to crystal field theory, negative ions should cause large crystal field splitting, but anions are at low end of the electrochemical series. So we have seen the electrochemical series, right? Do you remember the electrochemical series? This is the electrochemical series. Here we can see these anions are at the lower energy end of the series, whereas Neutral ones like ethylene, diamine, carbonyl, and ammonia are having higher energy. So this is also not explained using the crystal field theory. Also, the covalent character of metal ligand bond is not considered because the metal ligand bond is considered purely ionic. So these all are the main drawbacks of the crystal field theory. I hope everything is clear in this class. If you have any doubts or need any